Alright, we are live. Today we're going to be doing a quick and short stream. I'm going to do a div 3 and then see how that goes, and then afterward, if we still have a bit of extra time, we can just talk about the Open Cup that just happened earlier today. And so, yeah, I'm curious if anyone in the chat has or just did the Open Cup. I'm curious what problems you might be interested in just going over. So if you did, let me know. Hey, Keklux, good to see you again. All right, let's see. So today, I'm planning to just jump into round 74, div 3 right here. Hey Ahmed Alawadi and hey Bitboard. Good to see all of you in here. Yeah, so we're just gonna get this set up. I'm gonna go for hey SM Sugar and Wine, nice to see you too. All right, I'll start in about a minute. Yeah, how's it going for everyone? There's definitely been a lull in contests this weekend, especially on Codeforces. There's pretty much nothing this weekend, so curious what you guys have been up to. Have you been practicing other problems? Do I participate in ICPC? I did. I participated in ICPC 2012. Let me see if I can pull it up. Long break, it's kind of annoying. I like how you said long break, like it's a type. But is this? Oh, this is 2019. Okay, I'm not sure how to show 2012 exactly, but I did enter in 2012 and we got a silver medal, so that was a pretty good result. Yeah, well, the long break, that's definitely one of the reasons that I set up a couple streams this weekend, just to, you know, get some more competitive programming content out there for the weekend. All right, let's see, about to go. So I usually like to open up the complete problem set so I don't have to click a bunch of links. All right, let's see. Oh, I forgot to generate the samples for this round. Okay. So Vasya goes to his classmate, Petya. Okay, I see. So we're trying to figure out which floor apartment N is on. The first floor has only 2 apartments, 1 and 2. And then after that, every floor, second floor, third floor, and so on, have X apartments. So it's going to be numbered from 3 to X plus 2 for the second floor, and then X plus 3 to 2X plus 2 for the third floor, and so on. And so we got to figure out which floor number N is on. So yeah, this is a pretty simple just task. It's like, let me generate the I think we have 6, yeah. It's basically just dividing by X, but the situation with the first floor makes it a little bit funky. So yeah, basically if N is 2, then we would just want 1. Otherwise, it's otherwise we want n minus 3 and then divide that by x. So n minus 3 basically converts this range 3 to x plus 2 into 0 to x minus 1, which will all divide by x into 0, and then we'll get the second floor. And then same thing for the third floor and so on. It'll just give us the right floor. So we can check that out. Looks good. Submit that. So I was Harvard University for ICPC. Hi, Aminatreb. SM Sugar and Wine asks, will I be talking to the problems? Yeah, so I'll just go through each of the problems as I'm working on them. And so, yeah, if there's anything confusing or I didn't explain enough, just let me know in the chat, and then I will just make sure, the explanation is clear. Okay, problem B. Masha has n types of files, size 2 by 2. Okay, so this problem is, so far it's mostly a reading problem. I'm still trying to figure out what the problem is asking exactly. So we have a bunch of different options of 2 by 2 tiles, and each 2 by 2 tile has 4 numbers, and we need to build an m by m square consisting of these tiles. It needs to be symmetric with the respect to the main diagonal. Okay, so first of all, m has to be even, right? Yeah, okay, so this is one test case, and then this test case, m is 5, and the answer is no. Test case. Okay, yeah, so m has to be even, otherwise we can't actually fill it with a 2 by 2 or a tiling of 2 by 2. And yeah, basically the other thing we have to have is, so for the diagonal itself, for the tiles on the diagonal, we just need them to have the top right equal to the bottom left. And then if there's anything not on the diagonal, it has to basically we need one that's like a flip, a rotation of another one. And it turns out if we have the tile that works on the diagonal, then you can, do that flip to make it match itself. So for example, this 5774 tile, we could have, instead of this 8998 tile, we could have just put that 5774 tile here as well, and that would have also worked. So we're actually just looking for is there any tile where the top right equals the bottom left? And if there is, then we can just fill the we can just fill the entire matrix with that. Okay. yeah, and basically, yeah, for this problem, you can just kind of take a minute to kind of convince yourself that that works. In order to get to this, we just, analyzed for a tile on the diagonal, what does it have to do, right? And then for a tile that's not on the diagonal, what does it have to do? And it matches up with some other tile. So for example, these two in particular, and they have to be reflections of each other. And yeah, so pretty simple. It turns out that as long as we can fill the diagonal itself, we can just fill the rest. And so yeah, we can just code that up. Let me see. So we have n and m. And if m is odd, it's just no immediately. Oh, but so this is the funny thing about multiple test cases. We can't actually just do this and return here because then we didn't read the input properly, right? So we actually do have to go ahead and read the tiles. So yeah, we're just going to say that, and we're going to see if we just want a tile where, like we were saying earlier, the top right equals the bottom left, so that's just b equals c. And yeah, basically it's yes if we have a diagonal and m mod equals 0. Okay, so let's try that. Looks good on the samples. Okay, we're good. Yeah, so this problem was kind of funny because honestly, reading the problem and understanding it was the majority of the time. Yeah, so sometimes you get that type of problem. Strategically, it's an interesting situation because if you have a really long, hard to read problem, it might be worth skipping to the next problem first in a contest if you feel you have a good chance of solving that one as well, or if you feel you have a good chance of solving that one quickly as well, because it might end up better given that it's shorter to understand and solve. Okay, so initially we have an array. I see. Okay, so in this problem, we start with an array that just has one element, which is a 1. We have two operations we're allowed to do. The first operation is pick any element of the array and then increment it by 1. The second operation is to take any element of the array and copy it and add it to the end of the array. And so this is an example of what you can do starting from the array 1. You can copy the 1 to get 1, 1, increment the first thing to get 2, 1, copy the 1 to get 2, 1, 1, and so on. And then we want to get a sum of at least n with a minimum number of moves. So on these types of problems, generally you want to figure out, okay, so I have these operations. Is there some order that makes sense to apply them in? And in this case, on this problem, it makes sense to do all of the increments first before we do any copying. And the reason for that is if we copied a number and then afterward we incremented either of the copies, we could have just done the increment first and then copied, and we would have a bigger sum. And so the only strategy that really makes sense here is to increment this 1 a bunch of times and then make a bunch of copies of it, of the resulting number. And so we're going to take the 1, we're going to increment it all the way up to x, and then we're going to make y copies of that x. And again, you can think about it as if we made some copies and then we incremented one of the x's, we could have just done that increment earlier. So that's the reason. So basically, if we do that, then so for 1 to go to x, that costs x minus 1, and then to make y copies of it, that costs y minus 1. And so in order to get a sum of x times y, that will cost x plus y minus 2. And in this case, we basically want to make x and y as close as possible. The reason for that is if you're given a certain amount of sum, basically, and you want to make the product of the two numbers as big as possible, it's best to make them as close as possible. There's a couple of different ways you can prove that, but it's a kind of a standard known fact. So in this case, we're given numbers up to 10 to the 9th. And then, yeah, we need to figure out how to get a product that big. It turns out for this particular problem, we can just actually do it in square root n time if we want to. Just start x at 1 and y at 1, and then alternate incrementing them until we get big enough. If you want to do it faster, you can just take square root of n and do a couple cases around that. So I'll do the faster method. Basically, we'll take n, and then we'll take the square root of that. And one thing you can do with this type of problem is you can just kind of be really safe by just doing, a couple iterations around that number. We actually want 1. Yeah, I think in reality we only need to consider s times s and s times s plus 1, and perhaps let me think for a sec. Yeah, perhaps s plus 1 times s plus 1, and I think that should be sufficient because this is definitely big enough. And then if we want to get a sum smaller than this, then these are the only real options. But then, doing this loop, it's still constant time, and it's just like definitely less error prone. There's no way even if you did this calculation off by 1, you'll still be safe. Okay, so let's submit that. Let's see, we got a couple questions. How to debug code in Linux. So what do you mean by Linux specifically? Because it's roughly the same in terms of context code, regardless of what operating system you're running. The main things that I do are, the first thing is just reread my code, right? That's just a good way to catch a lot of things where I'm like, oh, I actually forgot to do this, or maybe I'll notice earlier, for example, I started from 0, but I actually realized you need to start from 1. And then other techniques, printing out intermediate values is definitely helpful. If you get a segfault, you can use GDB to just immediately catch what's going on, and that's super helpful. And yeah, another thing you can do is stress test your code. It's kind of a last resort in some sense, where you write a slower solution and then run a bunch of random test cases and compare your solution and the slow solution. But that's a longer topic, so I won't get into that too much for now. Yes, I will try to upload these to YouTube. I'm still working on the last one. I'm getting some YouTube processing issues, but we'll try to work through that soon. Binary search to find how big to increment the first value. So binary search, I'm not sure if it would make a ton of sense here. You're basically just looking for the square root to get, or somewhere around the square root to get the best sum. Okay, yeah, let me grab the channel link for you guys. So 18, Boo, Pender, yeah. So your name is a little long. So the segmentation vault situation, I actually had one of those in the last stream yesterday. So you can check out, I think it's in my Twitch videos, but if not, it'll be on that YouTube channel soon. So you can check it out there. And yeah, I actually go through finding a seg fault in GDB. And then SM Sugar and Wine says, could you talk about your setup after the contest? Sure, yeah, we can do that. Hopefully we have a bit of extra time. Okay, let's jump into problem D. So we've got an array, positive and negative, but no zeros. Okay, so we've got an array. There are no zeros in it, but they can have positive and negative integers. And we don't want any subarrays to have a sum of 0. And when we're thinking about subarray sums, what you should often immediately think about is prefix sums. So for example, if you have A1 through AN, then A1 plus A2 plus A3 plus A4 is a prefix sum. And the point of that is that any subarray sum is one prefix sum minus another prefix sum. And so when we're saying no subsegments or subarrays sum to 0, we're actually saying that no two of the prefix sums are the same. So that's the power of prefix sums here. And then the thing that we can do is we can insert integers in between elements of the array. And we want to insert the fewest number of times to get basically no equal prefix sums. And so I think one thing that comes to mind immediately is that if we make this prefix sum array, so for example, we could take, okay, so let's take the first sample. And the prefix sums will be 0, so remember to include a 0 at the beginning. This is for the empty prefix. And then you have a sum of 1, and then you have -4, and then you have -1, and then 1. And so this is just, for example, -1 is there because it's 1 plus -5 plus 3. And so here we can see the only problem we have is that this one here and this one here are equal. And so we're going to need at least one insertion to fix that. And then if we think about it more generally, if we had, let's say the most frequent element in the prefix sum array were x, so it looked like x, and then another x, and another x, then how many insertions would we need to fix these x's? So when we do one insertion, what's actually happening is that basically every sum past some point increases by the number we inserted. And we also create a new one more new prefix sum, which is the sum right before it plus the new number. And then the problem actually states that we can pick any type of number we want. We can pick like positive, negative, even a huge number that it can't even be represented in most programming languages. And so one thing that would be convenient here is to pick just like, 10 to the 100th, right? Some huge number, where that way we know for sure that nothing that comes after that number in the prefix sum table will be equal to anything before. And so all we can really do is we can just pick some big number, and so we can change all these to x plus big, right? If we insert the number in between these two x's. If we insert it in between the second x and the third x, it would look like this, right? And so it's clear that we need, if the most frequent occurring number occurs 4 times, it's clear we need at least 3. And then that's not necessarily enough though, because we can have a situation where it's like, for example, 1, 1, 1, 1, 2, 2, 2, 2 might be the sums. I guess that's not allowed because 0 is not allowed, but you could have something like this. And so, yeah, in that case, we do need to insert something in between all of these kind of ... sections. And so we would need at least 6 for this particular case. Yeah, basically, I think in general, there's a pretty simple greedy algorithm where you go through the prefix sums, and whenever you see something that matches the prefix sum from before, you just insert like a huge number right at that point. And so for this case, we'll go through here, and then we'll see this. And so everything after here will just become 1 plus b. Right, and then we'll remember that we have a sum of 1 plus b, and then we'll go here, and we see 1 plus b again. So we actually need 1 plus 2b, right? And so everything here becomes, again, 2b, and so on. And so we'll end up like doing one here, and then we'll do one here, and one here. And so in this case, we inserted 6 b's, where b means big number. Yeah, so I think in terms of implementation, we don't need the cases here. Basically, it should look like this. So this is just how you compute them. And I guess we'll keep a map, maybe a set of the sums. We'll call them current. And int changes equals 0. So we're just going to go through the sums. And we're going to try to insert the sum. And we can actually use the return value of insert. So if you use .second, that gives you true if the insert succeeded and false if it didn't succeed. So in other words, false means that the sum is already in the set. And so if it's already in the set, then what we're going to do is we need to change here, and we're going to clear the set, but we need to remember that we do need to insert this sum again. Yeah, so I think we should be good with this. Oh, it looks like we have an issue. Let me see. Okay, so I'll put it 4, accepted is 6. So me take a look at this case. It's possible that we, oops, what happened here? Okay, it's possible that we mess up something in between when we insert these big numbers. So let me take a look. So the sums would be okay, and so we're going through, and then we see this sum of 0, and so that tells us we need to insert a big number here, basically. And so now our sums become b minus 1 and b, and then we have b minus 1. Oh, I see. Okay, so the problem is that we need to consider that we inserted this number right before our last number, so we actually need to insert two sums into our set. The other sum is the previous sum right before this, because basically what happened here is this is the original array. We started at 0, we got a sum of -1, we got a sum of 0. And so we're like, oh, we need to insert a big number here. And so from now on, everything, we can ignore every sum that doesn't include this big number because it's definitely not going to be equal to any future sum. But we need to include the sum -1 plus b and then -1 plus b plus 1, which is b. And so I don't actually want to deal with b, so I'm just going to call this -1 and I'm just going to call this 0. But the key thing is we need to insert both of these sums in instead. And so, okay, so that's why we inserted prefix sums I minus 1. So let's give that a shot. Okay, we're accepted. No, Scott and I are like enough years apart that we were not in school at the same time. The question, what if the prefix sum is 0? So the prefix sum is 0. This is an important case where you want to make sure you include the empty prefix. And that's why we start with this, with I equals 0 here. So basically, prefix sums 0 equals 0. Prefix sums 1 equals A0. Prefix sums 2 is A0 plus A1, and so on. And so if A0 plus A1 is equal to 0, we'll notice that prefix sums 2 is equal to prefix sums 0. How am I running the code? Yeah, so this is actually a script that I wrote to just run all the samples and then check if they match or not. And basically with some like fancy terminal stuff, you can get this nice green color or red depending on whether you pass or not. And so I just set that up. Wouldn't a map be a better thing to use here? So a map is also fine. It's just that we don't really need the value. We just need the key. We're just trying to determine if the key already exists. And so the set is fine because we're just trying to insert and see if that works or not. Yeah, when multiple answers are possible, it won't actually work. Like it does not have an automatic judging program. That would be something, but it's not that far. So it'll just say you failed even though you passed. Why do I not prefer bits standard C++.h? So personally, I like just having a shorter list of includes. One reason is that you have fewer potential name conflicts with things by not including everything. And the other thing is that it does increase your compile time a bit. And so it's just a personal preference. I don't think it's a super big deal. I mean, maybe, including it is like, maybe I should for like slightly faster coding time, but it's not that big of a deal to me to just add an extra include up here when I need it. Andrew says, don't use namespace standard. Yeah, so that's true. the more like proper programmer canonical way to do it is to not do this and then use standard everywhere. But I think that gets a little bit too annoying for a programming context where you're like standard cout something, standard endl every time. Or actually, you shouldn't use endl in general, but that's another topic. But then yeah, you'll have standard vector, standard string, like it'll just get a little too long. How a beginner should start. So this is a very often asked question. I think there are a lot of different approaches. I think the main thing is just to jump in and do a lot of different problems and go for problems that are reasonable difficulty for you. So make sure you're doing problems where you're learning things as you're going. And yeah, I mean, you can check out, I think Scott's AMA had a good answer about this. And then, yeah, Frightened Swan pointed out that Ricto and William Lin have made good videos about this too. Okay, let's jump into E. Okay. Okay, just explaining how rock, paper, scissors works. Okay, so they just play n times, and then you know the number of times Alex played rock, scissors, and paper, and then the number of times Bob played each of them, and you're just trying to find the max and min number of rounds that Alice can win. So the first thing we notice is that n is huge, so we can't just like do any sort of brute force or anything. We need to, come up with some smart method, basically like a more or less an O of 1 solution. And the other thing that I noticed is that these two problems are pretty much the same. We can just, for example, if we can solve the minimum number of rounds Alice can win, then we can just solve the, well, I guess it might be a little bit different. I was gonna say we can just do the same for Bob, but because of the draws, it's a little bit different. Okay, so if we're thinking about this, then let's think about minimum first. So basically, we want to minimize having Alex with rock, and then Bob with scissors, and then Alice with scissors, Bob with paper, and then Alice with paper, Bob with rock, right? And so there's kind of 3 types of pairs that we want to avoid. And we want to see basically how many times can we avoid them. And okay, so let me think about this. Okay, so actually maybe we can solve maximum first. I feel like that is a little easier. So, well, one silly thing we can do for maximum is we just have a bipartite maximum matching problem where Alice Rocks connects to Bob Scissors. Alice Scissors connects to Bob Paper. Alice Paper connects to Bob Rock. Right, and so we can just, if we just find the maximum number of matchings in that graph, that's the answer. I think we can just implement that greedily as well, where we just add up the min of Alice Rock and Bob Scissors, and then add up the min of Alice Scissors and Bob Paper, and so on. And that will just clearly be the maximum. And it's also always achievable because you can just match those up, and then you have a bunch of leftovers, and you can just do whatever with those leftovers, and it doesn't really matter. And again, we can just use int64. There's no reason not to. So the maximum is going to be basically min of A0, B1 for Alice Rock, Bob Scissors, yeah. Plus min of A1, B2, plus min of A2, B0. So we can just do this to check our line of thought now. So we are matching up with each of these. Okay, and then we just need to solve minimum. So I'm trying to think about if there's a way we can just greedily match to get the minimum. And I think the funny thing is, again, we could solve it by using maximum matching. Now we're just trying to get the maximum matches where every match is either a draw or a loss. And so we would have a graph with 3 nodes on each side. Feels like there should be a greedy of some sort here, but it does seem a little bit complicated. For example, if you have Alice Rock, then it's not immediately obvious whether you prefer Bob Rock or you prefer Bob Paper to match those up with, because which of the two you prefer depends on whether Alice has more of scissors or paper. Yeah, and so actually I guess I will, just for the fun factor, I will just throw the flow solution at this problem. So I am copying my flow code here. And let's see. Okay, so we're gonna have a graph with 8 nodes. The source is gonna be 6, the sink is gonna be 7. And so basically it's gonna look like And then there's going to be some like connections to the other side. Oh, sorry. And it'll look roughly like that. There will be some of these connections in here, for example. And basically, the source is going to connect to 0 with the capacity of infinity. Same for 1 and same for 2. And then we're also going to have oh, sorry, this is not correct. This needs to be A0, because this is the number of Alice rocks that we can make. B0, B1, B2, and then what happens is so Alice rock beats Bob scissors, Alice scissors beats Bob paper, and so on. So as long as j is not I plus 1 mod 3, then we can add a directional edge between I and then 3 plus j with infinity. And so then the minimum is going to be n minus the flow here. And the reason it's minus is because we just did the maximum number of matchings where we do not win. And so the number of wins is just n minus that. So let's give that a shot. Oh, what happened here? Oh, I forgot to add sync. Okay, looks good. So that was a pretty funny overkill solution. But again, because it's a graph with 8 nodes, it's still constant time, which is funny. But interesting. I did this too, except you can manually enumerate all possible cuts. Okay, so that's a smart idea. So you can think about it as the flow solution, but then instead of actually coding the flow solution, you can just think about solving min cut. And so you can just you can kind of just go that way, and then you should be good there as well. Yeah, I'm curious if there's like a good greedy solution that doesn't really think about flow or cut. Got a couple questions. So why did I do LeetCode extensively for a while and then gave it up altogether? So I actually got into doing LeetCode because my girlfriend and a couple friends were practicing for interviews, and so kind of just did it along with them and started doing a decent amount of them. And then yeah, I guess I just got a little bit bored and started doing more of like Codeforces and other contests instead. But maybe at some point I'll do more of it again. I don't know. Would I submit a solution without proof? I've definitely submitted a lot of solutions without proof before. I even did that last stream on the last problem. Yeah, so often on problems you can do a bunch of examples and notice a pattern, or you can code up some experimental code to test a bunch of things and find that a pattern holds. And so in contests, it's not really worth taking the time to prove it if you can convince yourself that it really does hold for a lot of examples, because you're trying to solve the problem faster. And so yeah, I definitely have done that a lot of times. Why do experienced programmers like me and Kennedy prefer vector rather than array most of the times? So I used to do this thing where I always made like nmax equals 100,005, and then I would do this. The main thing is just, personally, I think that the code is a lot nicer when you don't have a constant where your code just breaks if the n is bigger than that. Yeah, also it's definitely nicer code if you can avoid having a lot of globals, as Andrew is pointing out. And then the other thing is that C++ is really nice because vector is actually super fast as well. So there's really no time issue, whereas in some other languages, you might have to be more careful. One case that I do sometimes still do the kind of nmax and make an array thing is if I have, for example, a 3-dimensional DP array. At that point, it's just a little bit too ridiculous to do like vector, 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 int, DP equals vector, vector, or equals like n, and then I do vector, vector, right? All of that stuff. So yeah, at that point, I'll just do a constant array. Yeah, Andrew has this like many 100-line code specifically for that situation. Okay, anyway, let's jump into problem F. Yeah, talking about tensor. Okay, we've got A, B, C, and question marks. Okay. Mm-hmm. The number of subsequences A, B, C. Okay, so not substrings, but subsequence. Yeah, so basically we're given this type of string. The question mark is allowed to be anything from A to C for all of them independently. And then if we imagine we generated all of these strings, we want to count how many times the subsequence ABC occurs. Okay, so yeah, that's a good point, Andrew. So sometimes there are problems where you're given a grid and you're given a guarantee that the area of the grid is at most 200,000. And in that case, you can't actually just make a single fixed array that accommodates that. Okay, so for this problem, my immediate instinct is that when we're counting ABCs, I think what we want to do is count them all via the B. So basically, when we iterate over the string, we're going to say, okay, if this is the B of the ABC, how many are there? And that way we just need to, like the A and C become independent, which is nice. We just need to count how many ways to get an A before that and how many ways to get a C after that. So for example, for this particular B, there are, it's a little funny. So there's like 3 ways to get this as an A, because this could be 3 things. And then there's 1 way to get this as an A. So that'd be 4. And then similarly, we have 3 for this, and then 1 for this. Does that make sense? Yeah, so basically for this B, the answer would be 4 times 4 is 16. And then this could also be a B. In that case, we have 1 way to get A, and then we have 4 ways to get C here, so that's another 4. Similarly, if this is the B, we have 1 way to get C on the right, then we have 3 plus 1 way to get A, so that's another 4. So it's 16 plus 4 plus 4 equals 24. So basically here we need to kind of figure out for each prefix of the string, how many ways to get an A, and then for each suffix of the string, how many ways to get a C. And for actual C's in the string, it ends up being just 3 to the power of number of question marks. And then for question marks, it's 3 to the power of number of question marks minus 1. So you don't include that own question mark because it has to be a C. And that would be for suffixes. And then similar thing for prefixes. So I think we can just compute all this. Yeah, I think it should be relatively simple. So let's just give it a go. So I'm jumping in to coding sort of a little bit early. I think if this were a real contest, I might want to think for maybe 2 more minutes before jumping into code. But in this case, I will just give it a shot and we'll see. And then we have a string s. Okay, so what we're going to do is we can make a function that solves 2 things for us. I think. Okay, so actually first let's do something so we can figure out how many question marks there are. So we'll do prefix questions as an array, and then if we want to get question marks for any subarray from start to end, or substring, we'll just do this. And that takes care of that. And so now let's say we're doing yeah, we're trying to solve for basically the a prefix. So a prefix 0 is going to be 0 because there's no way to get an a from the empty prefix. And then so we basically have 2 cases that increase the number of a prefixes. So basically if, I guess we can just do all of ABC. Or maybe there are 3 cases. Okay, we'll do 3 cases here. If the last character is an A, then a prefix I is going to be a prefix I minus 1 plus one other thing we can do is we can save powers of 3, so that would be helpful here. Yeah, so if our last thing is an A, then we have the same number of ways as before, or we can choose this one, which results in P3 of prefix question I. Another case is if it's, if it's a question mark, and then otherwise if it's a B or a C. So if it's a question mark, then what we have, let me do this instead. I think this will be a little bit nicer. If it's a question mark, then we actually have 3 times a prefix I, because if we pick something before this, then we have 3 ways to pick this current character. Otherwise, we have this again, if we pick the current question mark. And so notice that this prefix does not include SI, and that's important. And then otherwise, it's just the previous value. And then we're going to do this for suffixes as well. C suffix. If it's a C, then C suffix I is going to be C. Oops. I plus 1 plus P3 of, I guess now we need to use get question, which is we're going to be counting the number of question marks from here to the end. So just like that. So this is just, again, just very parallel to the above. And then finally, we're going to get our answer. The way we do that is we iterate through each character, and it can be a B if and only if it's a B or it's a question mark. In that case, we want to add a prefix I times c suffix I plus 1. So the point is that a prefix I does not include I, and c suffix I plus 1 also does not include I. And that should be our answer. So let's give that a try. Okay, so we're into a little bug here. So now when we're debugging, one thing we can do is let's check out these two arrays on the first example and see what we get and see if it makes sense. So a prefix, so for 0 it's 0. At here it's 1, which is right. There's only one way to get an A. For AC it's also 1. And then for AC question mark it is 4. And that makes sense because we have 1 from this question mark and 3 from this A because we have 3 choices of the question mark at that point. And then after the 5th prefix, it's 15. And that looks right too, because it's 9 plus 3 plus 3. So I think A prefix is correct. It looks like C suffix is the one that is too big. Yeah, so we're getting 6 here for some reason. So where did that come from? So this, the last one is 0, that's correct. The second last one is 1, which is just the C, and that's correct. And then question mark C should be 4 the same way this is 4, but we're getting 6. So let's take a look here again. So here's the problem. So prefix question I does not include I, but when we did this, we actually did include I. So we, again, need to do the same thing as like this, where we skip to I plus 1 so that we exclude I. And so I think that was the problem. Okay, looks pretty good. Yeah, let's go and submit this. Okay, we got AC. Nice. Looks like we got a couple questions. Where can I find your template? Yeah, so unfortunately I don't have my book code, my library code open source right now, but I am planning to do that in the near future, so, or somewhere in the near future, we'll see. So I will let you know if that is ready. Right now it's a little bit complicated because it's like a little too intertwined with the rest of my code, but I'll try to separate it out at some point. Can I explain F again? Okay, so F, basically the main idea was to count ABC subsequences via the B. The reason is that it separates the A and the C, and we can count those independently and then multiply. And then the key thing is we can look at the first example. So for this B, how many ways can we get an A from this prefix? And then how many, oops, it's AC question mark. And then how many ways can we get a C from this suffix? And then we just multiply those together. And so for this prefix AC question mark, the number of ways we can get an A is, for this A, if we pick it, there are actually 3 ways we can get an A from it. Because there are 3 values for this question mark. So it's ACA, ACB, and ACC. And then for this question mark, there's 1 way we can get an A, which is to make it an A, right? And so the key thing there is that for the prefix, if I want to get an A from an A, then the number of ways to do that is just 3 to the power of number of question marks in the prefix. And then if I want to get an A from a question mark, then it's going to be 3 to the power of number of question marks minus 1, because we've decided that that one particular question mark is an A. And so we're just adding that up. I guess another way we could do that is we could have just counted the number of A's and counted the number of question marks in the prefix, and then just done a little bit of multiplying, and that also would have worked. And so that's basically what we're doing here. We're just calculating that with a prefix. And so a prefix gives us the number of ways to get an A from a prefix. Similar for C suffix, and so that's why we're just multiplying them together in the end. And then you just have to make sure that your current character is either a B or a question mark, because those are the only things that can make a B. Yeah, I guess we could actually do A and then AB and then ABC as well, which is what Smart Coder 89 is saying. That way we get kind of just building on prefixes. So we're doing a DP where we're adding one character at a time. And maybe that code will be a little simpler because then you're just doing a nested loop of 3 by n. The way that also makes sense, yeah. The way that I thought about it was just focusing on the B, but it looks like that's true, you don't have to do it. Let's just check the standings out of curiosity. Okay, so it looks like Andrew is again at the top of this one, which is pretty funny. He was at the top yesterday as well. Andrew has 3 times less penalty than us, so that's pretty impressive. Nice. Yeah, were there any other questions about anything from this round? Yeah, otherwise I think it didn't seem like anyone in chat had any, or actually did the Open Cup. I'm not sure if there was any particular problem from Open Cup that people were curious to discuss. Then, yeah, just post it in chat. Otherwise, that might just be it for the stream. Yeah, thanks for coming, Smart Coder 89. Yeah, enjoyed having you here. And yeah, that was a good point about the A, AB, and ABC solution. When is the next stream? So I haven't decided yet. I might shoot for potentially next weekend, but not sure yet. So I will just keep you posted, and I'll post it on Codeforces streams when I do know. What Intellisense do I use in Sublime? So, are you talking about the debugging here? Actually, it's not. Oh, wait a second. I guess clang D is here. I'm not sure why it's... So for example, if we make a compile error. Yeah, so, okay, earlier, I don't know why it's not happening now, but earlier I was getting some kind of sort of pop-up here with compiler errors. Is that what you were asking about? So that was specifically clang D. This is actually something that Andrew recommended to me recently. You basically set up LSP with, maybe I need to do this. I think it's already enabled. I'm not sure why it's not showing up. But you set up Sublime with LSP with Clang D, and you get just like compile checking as you go. And so that way you know right away if you have some sort of error warning. Yeah, if someone knows why it's not showing up right now, let me know. I'm not actually sure. But will I ever do screencasts of unrated contests in the future? Maybe I could do that. Are you guys curious to just see like my general process? Yeah, I mean, I've started doing streams to just like help show people some of that. So yeah, if screencasts are also helpful, I can try to start doing some of those too, and just upload to YouTube, I guess. Let me see. Can I try this any code problem? I think I'm actually going to end the stream now. So sorry, I'm not going to do that today. Maybe if you guys have specific problems that you're curious about, let me know. I could get to that another time. Yeah. Thanks for coming, SM Sugar and Wine. Yeah. Enjoyed having all you here, and yeah, it's just fun to work on some problems and explain them along the way. Okay, yeah, and I think Andrew is streaming now actually, so he said he would try solving some problems in Rust, and I know he's been talking for a while about how Rust basically fixes a lot of the complaints he's had about C++, so it'll be interesting to see. Yeah, so gonna end the stream now. Let me see if I can raid Andrew. Okay, here we go. Yeah, thanks everyone for coming. I'll see you guys next time.